In this video, we have some limits to evaluate. Statement here states evaluate each limit using L'Hopital's rule where necessary. Now let's look at the statement for L'Hopital's rule. States if the limit of some function f of x over g of x results in the indeterminate form, could be 0 over 0 or infinity over infinity. Should also work minus infinity over minus infinity. If that's true, then the limit of f of x over g of x will equal to the limit of the derivative of f over the derivative of g, f prime over g prime. Notice this is not the quotient rule. It's just the derivative of the numerator over the derivative of the denominator. And that's provided this limit exists. So that's what it states here. So let's look at the first one here. Normally when you evaluate limits, you just plug in the number. If you get a number, that's your answer. So for this one, let's just plug in 2. Got the limit as x goes to 2. And again, over here in the form, in the statement here, this could be x goes to any number. X goes to 2, minus 1, goes to infinity, minus infinity. That's why I didn't put those in there. X can go to any value, or it could be infinite. So let's plug in 2 here. So 2 squared here would be 4, and then it'd be a minus 2 there, and a minus 2. So plug in 2, we get 2 squared is 4. This would be minus 2, and minus 2 is be 4 minus 4. That goes to 0. And of course, 2 minus 2 is 0. So that's the indeterminate form. Now for this particular one, it's not necessary to use the L'Hopital's rule, but let's go ahead and do it anyway. So it does go, first you test if it has an indeterminate form, and this does give you 0 over 0. Could be infinity over infinity. So it's going to work. Or at least it satisfies the conditions of the theorem. Take the derivative of the numerator. Derivative of x squared is 2x. Derivative of minus x is minus 1. The derivative of minus 2 is 0. In the denominator, derivative of x is 1. Derivative of minus 2 is 0. So that's what we have. This still goes to 2. Now you test it again. And if you get a value, that's your answer. So let's plug in 2. 2 times 2 is 4 minus 1 equals to 3 over 1. That works. So this is the answer using L'Hopital's rule. But this is one we could do and just using basic algebra here. So the limit as x goes to 2. Let's factor the numerator here. Goes x minus 2 here and x plus 1. And that's over x minus 2. Remember, when you compute the limit of an expression, in this case x goes to 2, we're looking at what happens. We're looking at what happens as x gets real close to 2. It doesn't have to get to 2. Now, normally we would say, well, you plug in 2, this is going to be 0, this is going to be 0. We divide it by 0. But we only want to know what happens if x is real close to 2, but not quite there. In that case, I can cancel those out. And then say, okay, what happens now as x goes to 2? Well, this cancels to 1, and this goes to 2 plus 1, which is still 3. So this is a case where I didn't really need L'Hopital's rule. I can do the work here, get the answer using algebraic principles here. Now for the next one, the limit as x goes to infinity. Well, let's look at this. Limit as x goes to infinity. This is going to get large, so it's going to be infinity. Denominator, x goes to infinity, well, denominator is going to go to infinity. Indeterminate form. So let's see if it works for this one. So it's going to be a limit as x goes to infinity. The derivative of ln of x is 1 over x. That's the derivative of the numerator. The derivative of the denominator is 1. So 1 over x divided by 1 is still going to be 1 over x. Now let's look what happens here. The numerator is constant at 1. X is getting large. This goes to infinity. So it's 1 divided by a large number that's growing. So we can say as x goes to infinity, 1 over x is going to go to 0. And that's your answer for this one. Now for number 3, let the limit as x goes to infinity of x squared plus 2x plus 3. So this one doesn't factor, so as x goes to infinity, the numerator is going to go to infinity. Denominator is going to go to infinity. Infinity minus 1 is still infinity. So we get the form, infinity over infinity. So let's see what we get if we try L'Hopital's rule. Take the derivative of the numerator. We're going to get 2x. plus 2. Derivative of 2x is 2. And the derivative of 3 is 0. In the denominator, the derivative of x minus 1 is 1. So in this case, the numerator got 2 and then plug in infinity here and the plus 2. This is going to go to infinity. 1 is constant. So infinity divided by 1 is going to be infinity. So using L'Hopital's rule, we confirm that the limit goes to, as x goes to infinity, this expression goes to infinity. So for number 4, get the limit as x goes to infinity of x to the 1 over x. This x here would be infinity. 1 over x as x goes to infinity would be 0. So that's infinity to the 0 power. That's an indeterminate form. So we can use L'Hopital's rule, but to make it a little bit easier, I'm going to rewrite this. As limit as x goes to infinity. This will be x to the 1 over x. We got that. And then we're going to take the log of both sides. Natural log of y. Take the natural log here. The 1 over x comes to the front using the properties of logs. This will be 1 over x. And then I have the natural log over x. And then I got the limit here. And then the 1 over x is right here. So let me just delete this part here. And I still have the limit as x goes to infinity. X goes to infinity, numerator goes to infinity, denominator goes to infinity, so it's indeterminate form. So I can take the derivative here using L'Hopital's rule. Then with this y equals to this right here. X goes to infinity here. Derivative of ln of x is 1 over x. Derivative of x is 1. 1 over x divided by 1 is still 1. Now let's take the limit as x goes to infinity. So all we have here is 1 over x here. As 1 over x divided by 1 is 1 over x. And as x goes to infinity, this will go to 0. So this is what we have. ln of y. Okay, all these calculations lead to 0, so ln of y is equal to 0. But we want to find y, because that's what this is equal to. Y is equal to this. So from this equation, we know then, using properties of logs, actually the definition of a log, if you have a log of something equal to a number, that means the base here, which is e, base is e, this is natural log, has to equal to this number. This is to the 0 power. E to the 0 is equal to 1. So that means this log, or this limit rather, equals to 1. So let me just write it this way. The answer then is the limit as x goes to infinity of x to the 1x, of x to the 1 over x. This is equal to 1. So that's the answer for number 4. Limit as x goes to infinity of x to the 1 over x equals to 1. Thanks for watching. We'll see you next time.